All right, everyone, welcome back. We are going to be doing 5.5 today, so we're going a little out of order, but I think the order will make a little bit more sense. So in section 5, we're going to be proving that triangles are congruent and specifically proving that they're congruent by what I call SSS or side, side, side. And so in this, we're basically going to use this postulate here for the entire section. So this one's really important. Make sure you copy this into your notebook. It says if three sides of one triangle are congruent to three sides of another, then the triangles are congruent. So yesterday we were talking about how all the pieces had to match, right? But in this case, if you use the side, side, side postulate, you don't have to show everything. You just need to show all three sides are the same. So in this diagram, you can see that we have a list here that segment AB is congruent to segment RS, segment BC is congruent to segment ST, and then lastly, segment CA is congruent to segment RT. And so when we have all three sides the same, we'll go ahead and fill this in here. Triangle what is congruent to triangle what? Well, remember, we're going to go in order. So if I start with A, go to B, and then go to C, then I need to make sure I go in order with the other triangle as well. So starting with R, going down to S, and finishing at T. So the two triangles are congruent by the side, side, side congruence postulate. So we're basically just going to do this theorem or this postulate several times. So on the first example, it says decide whether the congruence statement is true. So is triangle DFG congruent to triangle HJK? Now remember, we need to show all three sides are the same, but we also need to make sure the order of the letters is in order. Okay, so first of all, as I'm just kind of looking at this, I see that the shortest side is matching up, looks good. The second one here also looks good. Okay, the third one, same thing. So far, I agree that all three sides are congruent to the other three sides. Now we just need to make sure that the order of these letters that they gave us is correct. So they went from D to F down to G. So they started at the shorter side and then went across what looks to be a hypotenuse. So let's see if that matches up with HJK. They started at H, went to J, so short side, that's good, and then went across what looks to be a hypotenuse to K. So I would agree that these letters are in order. Oh my goodness. And so I would say, yes, it is true. I don't know what is going on here. I'll just erase that. Okay. So I would say, yes, this one is true. Let's look at the next one. Oh goodness, that's a confusing looking picture. Okay, so it says triangle ACB congruent to triangle CAD. Now, just by looking at this, it kind of looks like no, right? I see a 3 over here and a 4 over here. So just with that, I'm going to say no, but let's kind of double check everything. So the 3 right here is on segment AB, and segment AB matches up with letters C and D on the other one. So is CD the same as BA? Looks like no, and so I'm going to have to say that this is false. Oh my gosh, you guys, I don't know why it's doing that. Let's come back to it. Okay, we're good. So this one I would say is false. All right, next one. It says QPT is congruent to triangle RST. Now, again, I'm just kind of visually checking. I see all of them have marked segments that are the same, so that looks great. Let's see if the letters are in order. So they started with Q and then to P. So from Q to P is across the one that has the 2 marks. And then from P to T, which is the 3 marks. So they went from up the side that had 2 little hash marks on it and then down the one that had 3. So let's see if that matches up with RST. So they started at R and went to S. So 2 marks, looks good. And then they went to T. Ooh, that's not the same, is it? So because the order of these letters is not correct, I'm going to have to say that these are not congruent triangles based on this statement. So the question was, is this statement true? I'm going to have to say that it is false. Now, if I wanted to make it true, I could fix it, right? I could say triangle QPT is congruent instead to triangle. Okay, so Q to P, then T would be S to R to T. So the order of the letters is super important. I know we've talked about this before, but when you put them out of order, you're basically saying that different segments are the same when they're not. So be careful that those letters are in order. They're going to try to trick you on that all the time. All right, next one we have is a graph. I know you love this. It says, given these coordinates, determine if triangle ABC is the same or congruent to triangle DEF. So obviously the first thing we need to do is go ahead and graph these. So I'll do that real quickly. Make sure you label your letters or your points. That'll really help. So that is B, and C is at 4, 6. All right, and then I'm going to do my best to connect these here. Okay, so that one looks good. Now I need to do triangle DEF, which is at 5, 7. Five, 1. And 13. Whoa, 13, 1. Oh my goodness, I'm gonna need to move this around, aren't I? Oh gosh. Move this over here, see if I can do this best I can here. Let's see, 8, 9, 10, 11, 12, 13, 1. That is F. Okay, so we've got these segments here. Okay, so basically we're going to need to go through and find out the lengths of these segments to see if it makes sense. So if these two triangles are congruent, AB needs to be congruent to DE, right? So let's check those first. AB is how long? Okay, AB is 1, 2, 3, 4, 5, 6 segments, and DE is 1, 2, 3, 4, 5, 6 segments. So we're good there. Let's check another side. Let's do side BC. Now, based on the order of the letters up here, BC has to be the same as EF. So let's check that. So BC is 1, 2, 3, 4, 5, 6, 7, 8. And EF is 1, 2, 3, 4, 5, 6, 7, 8, 9. Is that right? Did I do that right? Let's see. From E to F. Oh no, it's 8. I can't count. It is 8. Okay, we're good so far. We do need to check the third side, and unfortunately, these two sides are at an angle, which means we can't count. So I do have to do the distance formula twice. Okay, to find the distance from A to C, I need to do the distance formula. Remember, that's the one where I always write these out ahead of time, and then I go back through and I fill in the X values and then the Y values. So we're doing A and C. So I'm doing the X values from A and C. And then I'm going to do the Y values from A and C. And then you guys know I always do it in the calculator all at one time. So I'm not going to worry about calculating partial pieces. I'm going to do all of it at once. And plus -2 minus 6 squared. So again, I type all of it in my calculator at one time, and I'm getting 10. So AC equals 10. Now I need to do segment DF and check the exact same stuff. So segment DF, I'll do it in another color. When I do DF, I'm still going to look at the X values together and then the Y values together as well, making sure I do minus in between and then a plus in the middle. All right, so from D to F, I'm looking at 5 and 13. And then I'm looking at 7 and 1. Again, I'm going to type the entire thing in my calculator all at once. So 5 minus 13 squared plus 7 minus 1 squared. And I'm getting 10. Okay, so segment DF is 10. So the third side is the same. AC is congruent to DF, and they're both 10. So that's a check. So based on the side congruence postulate, these triangles are in fact congruent. We found that all three sides are the same. That's it. All right, so the next two problems are proofs. These are going to be in your Flipbook. So all of you should have a Flipbook at this point, unless you haven't been in class. And your Flipbook is going to be the one that you're opening up to each day based on certain proofs. So in this proof here specifically, we're given two items. So make sure you write your two givens down first. So I have that segment RP is congruent to PS and RQ is congruent to QS. Now, before I go any farther, I'm going to take those two items that I wrote down and I'm going to mark the picture. Okay, so RP was congruent to PS, and then also RQ was congruent to QS. So I've marked my picture based on what they gave me. Now, remember, we just learned side, side, side. So right now you have side, side, right? You're missing a third side that they have. Now, if you look at the left triangle, do you see that we have a segment PQ, right? The third side is a PQ. And then if you look at the right triangle, we also have a PQ. So both triangles have PQ, right? Both of them have that one same segment. So we're going to use a property that we learned several months ago to include segment PQ. So segment PQ on the left is the same as segment PQ on the right. So when two things are congruent to itself, that's the reflexive property of congruence in this case. So we're going to use this property a lot. So kind of try to wrap your mind around it. Anytime that they're sharing a side, you're going to write that side down twice, congruent to itself, and then that's always the reflexive property. Okay, so do we have three sides now? Well, I would say we do, right? They share this third side. So we have three on the left, three on the right. These triangles are congruent now. So that's our last step, is to write that they're congruent. Oops. And the reason that they're congruent is side, side, side. Remember that this right here is always your last line, okay? And your reasoning for this one is side, side, side. Okay, on proof number 2, we're going to do a very similar thing here. This time we're going to use our definition of midpoint, right? Because you see it is giving us a midpoint. So go ahead and write down your two givens. And then I have AD. Okay, so before we move on from our givens, let's go ahead and mark our picture. Line 2 is probably easiest. We have AD is congruent to CD. So that one's good. Now, let's talk about midpoint. Remember, midpoint means point in the middle. Now, if you're in the middle, what do you know about the other ends, right? From the middle that way and then the middle that way is the same, right? If it's in the middle, it's equal on each side. Okay, so if B is in the middle of AC, that means that from A to B is the same as from B to C, right? If B is in the middle. So let's put that in our proof. We just marked something in our picture. Let's put it in the proof. Okay, so AB is congruent to BC. Now, how did we know that? How did I know I could mark those, right? What told me that? Well, because B was in the middle, that's how we knew. So that's the definition of what it means to be a midpoint. Okay, so now we have 2 on one triangle and 2 sides on another triangle. We need 3, right? Well, we're going to use that same thing we just learned a second ago. They are sharing a side. They're sharing segment DB. So segment DB is congruent to itself, right? And of course, that's our reflexive POC. Okay, that's basically it, right? We've got 3 parts on one, 3 parts on the other. All of them are sides. So we know what we were trying to prove is true. ABD is congruent to triangle CBD. And the reason that they're congruent is because of the side, side, side congruence postulate. Okay, that's it for today, guys. You do have an assignment, so make sure you check on Canvas to see what that is, and let me know if you have any questions. I'll see you later.